and what are the viscosity of the fluid, density of the water, and also some turbulence or velocity, whatever is there in the liquid or water. These are all the important parameters which affects the sedimentation process. Based on the particle size and also the result of sedimentation, the settling or sedimentation is being classified into 4 different types. That is discrete settling, flagellant settling, zone or hindered settling. Another one is compression settling. And that free settling means the individual particles will be settled down. There will not be any interparticle collision, because settling means what it's supposed to be. There will be a particle to particle interaction. Based on the particle to particle interaction, then there will be neutral charges. Based on the neutral charges, the particle will be interacting each other, and it aggregates the bigger size and settle down, or it makes the precipitate. But when the concentration of the particle is very less, at that time the particles are settled down independently without any interaction or combination with the neighboring particles. They are behaving like an individual entity. That is called free settling or discrete settling. And the next one is flagellant settling. This is nothing but flagellation involved in settling. Here the particle will be this will be happen when slightly higher concentration of particle in the water. Here the particle will interact, they collide, and there will be interaction forces between the two particles. Then the particle size will be started increasing, then aggregate into the bigger one. Then it will be settled. This is called flagellant settling. Hello? Huh? Okay. That is flagellant settling. In flagellant settling, here the negatively charged particles will be there. Those are all colloidal particles. And when the people are adding some of the chemical that is called coagulant, which neutralizes the charges, then the particle will become smaller particle into bigger one, and they may be settled down very fast. This is one of the important process in sedimentation or settling or in water treatment process. I will explain in detail in the forthcoming section. Another one is zone settling. Whenever the moderate concentration of particle is there in water, and the zone settling will be happening. And more or less, they are telling in general 8% of concentration or more than 8% is there. That time, this hindered or zone settling is taking place. Here, what is happened like aeration? I would have explained in the last class about the aeration. Here, the clear interface forms between the water and also above the water, whatever the air is there. And here, the settling velocity mainly depending upon the mass, because there will be an interaction, there will be a collision, and keep on the particle size are interacting with each other. The size of the particle will keep on increase, but they will behave like an entire mass, not like an individual entity. This is generally this zone settling is happening in wastewater treatment concepts. Those concepts we will discuss in the next unit, next block. Aquatic sludge process. Especially this concept is applicable in the secondary treatment of sewage or wastewater. There, this settling is very important process. Compression settling. Compression settling is happening whenever the concentration of particle is very high. And at that time, all the 4 types of settling is taking place. First one is what we are saying, discrete, flagellant, zone settling. All the 4 types of settling is happening. Along with these 3, compression settling is also happening. From the name itself, we can understand that whenever the solid concentration or particle concentration is very high, and this compression settling is happening. And in water treatment, wastewater treatment, whenever the clarifier is under thickener yes, existing for the treatment technique, there this compression technique is taking place. So about the clarifier, I have explained in the last class, I hope. Clarifier is a device where after flagellation, you want to separate out the residue from the clear supernatant. That device is called clarifier. The process of separation of residue from clear water from this residue, that is called clarification. About that also little more I'll explain in the next section. Now the comparative perspective about all these four settlings, we know that the compressive discrete settling is taking place at low concentration. And here if the particles are behaving like an individual entity. And the second one is flagellant settling. It is here the particles are behaving like with collision and interaction, and they are aggregating into bigger size. Here the concentration is little moderate, at 10%, 8% more than
Good morning, madam. This
yes,
is
sir.
Suresh.
Yes, yes. The concentration is more than 8%. This flagellant settling is happening. And zone settling is happening whenever the moderate concentration is there. Here, this sediment is behaving like a mass, whole mass. It is not behaving like an individual entity. And the final one is compression settling. In compression settling, whenever the particle or solid concentration is very high, that time compression settling is happening. But in general,
Madam, can we record this session?
Sir, it is recorded in university also. Now you can download from there, sir.
No, we sent a request. Actually, I sent a request to record in local, but someone need to approve that.
Then because I am not an authority, because it has to be approved by university. But whatever the session is going on, that university is also recording. The recorded matter will be there in the university website.
No, that no one is accessible, madam. Last week we tried.
So if you want me to in such a way, I will help you where you can download. Because
Okay.
I am not an authority to approve for this download, because I am not a host. No, university is a host.
Okay.
Understood.
Okay.
If
Okay.
I don't have issue to record it otherwise.
Okay, no problem. I think it is approved.
Otherwise, you talk with the Dr. Ashok. This particular section we want to record means they may permit. If they permit, you can do it. I don't have any issue, sir.
Okay. Okay. Yeah, you continue. I will talk to you.
Okay, okay. The final is compression settling. In general, when the sedimentation process is going on, all these four types of settling is taking place. Compulsory, it should take place. Finally, only this compression settling is taking place. Before taking place of compression settling, discrete, flagellant, and kindred settling, all these three are pre-process. After this pre-process, the finally compression settling is happening. So whenever the concentration is very high, so the like a clarifier, or in the secondary treatment process like activated sludge, all these process involved with this compression settling only. We are thinking that the sedimentation or settling process is very simple. No. When we wanted to do that water treatment technology, either water or wastewater treatment technology properly, this sedimentation will improve and increase the efficiency of treatment process, as well as which increase the purity of water. Why? Because we are all aware of it. The chlorination is the final stage of water treatment. After chlorination or disinfection, we are not doing any sort of treatment. But the thing is, when we are doing the chlorination, some of the protozoa will highly resistant to that chlorination process. Those protozoas, what they are doing, they will be binded with that some of the organic matter in the water, then that they cannot be killed. Such kind of organism can be removed by this sedimentation process. So what this sedimentation process people are telling, it is very, very important, and also which effectively remove many things, and also it is a pre-process which increase the efficiency of the entire treatment process. If the efficiency increases means we can understand that the cost of treatment is going down and the quality of treatment will be going up. Whenever these two concepts are playing, that means which improvise the entire feasibility of the process, and we can finally conclude that which will be the effective method For the total treatment of water, why we have to treat the water? What is the need to do the treatment? Any one of you, please? We are talking about all this treatment technology. What is the need to do this treatment? Hello.
Impurities present in the water.
What? Please, pardon?
To remove the impurities present in the water.
Okay, fine. Very good. Then, anything else?
To kill the microbes present in the water.
Okay, fine. Then,
To convert the wastewater into usable water.
yes, that is the main concept. Clear? For example, I would like to say for Hyderabad, we are getting the water which does not polluted much, you know that. But we cannot use that water directly because we have to make that water to be consumable. For that, we have to do the characterization, which is nothing but analysis of water characteristics. Then we have to adopt one or two things which is supposed to be as it should not be acidic. It's supposed to be free from all sort of problematic material. So that's what they are telling one sentence to make them to be consumable. That's all. For that only we are doing. So now the treatment technology, which it depends upon what kind of source initially you have selected for water supply system. Either the river or reservoir or lake, whatever it may be, what is that and how it is stagnant, how long it is stagnant, and what is the characteristics of entire water throughout the year, whether it is varied or it is constant or stabilized. Based on that, the treatment technology is being adopted. That's what in the last class I have explained. The main water treatment technology is screening, sedimentation, filtration, and the last one is disinfection. But based on the water characteristics, some auxiliary processes are being used to make the water to be or make the water treatment system to be more efficient, like aeration, rechlorination, activated carbon treatment, and also sometimes aeration is also the auxiliary process. Such a things we are adapting based on the characteristics of water. Similarly, don't say simply that we are doing water to remove. Yes, of course, that is true. When you do the boiling, also the same thing will happen, no? If you want to remove the pathogens, if you want to remove unwanted thing, if you boil it, it will come. But that is the process you can do that water at a very small scale level, at a domestic level or at a home level, you can do that. But when we want to do this community water or municipal water supply system, we have to make the water to be suitable for human consumption. In such a way, they have decided the treatment technology or techniques based on the original characteristics of water or initial characteristics of water. Now we have explained many things. Now we are in the stream of sedimentation. So what is sedimentation and what are the process of sedimentation? In sedimentation, what are the sedimentation tanks and types are available? Detention time, and what are the different types of sedimentation we have seen, and what are the factors which are all affecting the sedimentation process also we have seen. Clear? Now I am going to jump. Yes, ma'am.
Ma'am, water will be from different sources like ponds and municipal sewage water and industrial water. Different types of methods sedimentation methods are applied to that, or all methods are common to the same water?
No, which depends upon the characterization of water. For example, okay, wonderful question you have raised up. I'll explain nicely. Please listen. You take any source of water for water supply, any pond or lake or reservoir or dam, whatever it may be, a river, running water, anything. First, you have to do the physiochemical analysis of water. That's what you would have studied in third unit or second unit or something like that. Based on the physiochemical characteristics, now I'll tell you, you select some water source for water supply system. If the water is very clear, which is free from the smell, free from the turbidity and odor, then only we first select the water source. If the water is giving taste, but it is turbid and odor and color is there, we will reject that water, is it? But today, when you have taken the water, all these are all physical appearance. From the physical appearance only, we can decide the water source. Color is good, turbidity is fine, and odor is fine. Everything is fine today. 1 year is running nicely. But next year, when you are using the water color has changed. What do? You cannot reject that water source, no, because for municipal water supply system, they would have spent many thousand crores of money. So that time, what they do, based on the characteristics, if the color is coming, mean they supposed to remove the color, which it depends. If all the time the color will be there, all the time our color will not be there, we cannot decide, which depends on season and rain and some other human activity or industrial or sewage water disposal into the water sources. So what we have to do, we should have all the treatment techniques based on the characteristics we have to apply. But what are the 4 important treatment? Screening means which is nothing but you have to remove all the floatable waste. Second one is sedimentation. Sedimentation means what? Whatever the particles which are high dense than water, they will be settled down at the bottom. You're supposed to remove. And the third one is you have to filter it. The particle which are less dense than water and which could be absorbed or filter it up, through that you can filter it. And the last one is disinfection or chlorination. Here all the pathogens will be killed by chlorine dioxide or chlorine gases. These 4 are common and standard treatment technique. Now I will introduce into the auxiliary units or auxiliary treatment technology, those technology which depends upon the characteristics of water. For example, the color of the water is coming. Sometimes the colored water is coming. What to do? We should remove the color. For that, you have to adopt activated carbon treatment. Activated carbon is a kind of product which removes the coloring matter which presented in water, which depends upon the characteristics of water. Always the water color will not be there. Sometimes will be there. So anyhow, we supposed to remove. So we have to adapt that activated carbon treatment. So what that is called auxiliary treatment. And the second one is we are getting water from river or dam anywhere else, correct? Any plant material will come, that human body will come, that animals will come, insects will come, snake will come, whatever it may be will come. We do not know because we have not seen. All living things are called animals. All living things are built up with the organic matter. Either it may be plant-based or animal-based, whatever it may be, those are all called organic matter. Those organic matters, when comes in water, they will remove. During the screening process, they will remove. But some of the organic matter would have been degraded. Those organic matters are presented in water means they may be very big organic matter, but we cannot see what could be the component. At that time, when we want to remove the extra or excess load of organic matter, that time we have to adopt the aeration process. Aeration process means what? We have to supply the air to the water, make the thin film of air water. And the basic concept is you have to give the interface between water and the air is more. Then what will happen? The air will be entrapped in water. Whenever how much molecule of air is entrapped inside, based on that, some of the dissolved gases from water will be evolved, and also the big organic matter will be degraded into small organic matter. So now the organic matter could be in the manageable form. So when it goes to the next stage of treatment, the treatment process will be easier and also which increase the efficiency. At that time, that's what this aeration is also called auxiliary process. Whenever the water contains a lot of organic matter that will be identified from the characterization of water, that time you can adopt this technology. If the organic load is not much, then you no need to adopt aeration process. Clear? And similarly, pre-chlorination. Pre-chlorination means what? Anyway, we are doing the post-chlorination. At the end of the process, we are doing the chlorination. Sometime, if any dead body or dead animals are coming, the pathogens population may be more. That time, after screening or after sedimentation, they will do one more time chlorination process. Then they will remove the excess pathogens Why they are removing that stage itself? Because these pathogens are highly complicated substances, correct? It will be affecting every stage of treatment. To avoid that, they are doing initially pre-chlorination process to remove the excess population of pathogens. So this, if the excess population is not there, no need to do the pre-chlorination process. This is another auxiliary process. So like that, we have to do the process, and anyhow, at last, based on the concentration of substances, we have to do simply or free sedimentation process. If the colloidal particles are more, then we have to remove those colloidal particles through coagulation followed by flagellation process, then filtration process, and finally chlorination or disinfection process. This is the different stages of treatment. So 4 important treatment, whatever I have told, that is common for all the water sources, and whatever the auxiliary process I have told, which are all depending upon the characteristics of water. Is it clear? Hello? Is it clear?
Yes, ma'am.
Okay, fine. You have any doubt, you can clarify now itself. I'm going to the next stage level.
Ma'am, accessory process you have told, no?
What?
Accessory process. Additional process like.
Yes, that's what I told you. Aeration, pre-chlorination, activated carbon treatment and all. I said no. Sometimes they will do softening also, because the water hardness is more. They have to remove the hardness. When they want to remove the hardness, then that is, which is nothing but softening process, right? These 4 are called auxiliary process, or it is based on the water characteristics. It has to be decided. Not clear?
Clear, ma'am.
Is it? Okay, fine. So anything, because I have jumped all those things, but you have asked me very interestingly. I have explained. So anything more you want to tell, I will tell right now itself, because I'm going to jump into the next process that is very, very, very important. And most probably one question will come from the coagulation and flagellation. Okay. Okay. The next one is role of coagulation and flagellation in sedimentation. Anyone of you aware of what is meant by coagulation and flagellation? Coagulation means what? Coagulant or coagulation means what? Any idea? Hello?
The solidification, no? Is it a solidification?
No, no, no. Sorry. No. What? Then.
Coagulation means small particles will combine together and form.
Yes, yes. Okay. Okay. More or less you have explained, but specifically I'll tell you, please listen me. You have some idea, but it is not exact answer. You are telling that second part of coagulation, which is nothing but flagellation. Okay. Now I'll tell. I told you what is sedimentation. Sedimentation means, I said, the particle which are high dense in water will be settled down at the bottom when the water is in still condition. The term is very important, when the water is in still condition. And that time the higher dense than water particle only, water molecule only will be settled down. Now I am going to talk about the particle which are all near less dense than water. That will not be settled down, is it? If less density than water means it will be floating or suspension in water. And those particles are very minute particles. The particle size are typically they are telling 1 nanometer to come down to 1 micrometer size. Those particles are collectively called colloidal particle. Colloidal particle means what? Anyone have an idea? Those particles less dense than water, that is always remaining in suspension in water, but we cannot see by eyes. But that will be there. Those particles may be organic substances or inorganic substances, whatever it may be. Those particles are really problematic substances. Those should be removed from water by some process which adapted to make the particles into bigger size then it could be removed. Otherwise, those particles cannot be removed by sedimentation or filtration process. For that, what people are doing, they are adding some of the chemicals. Those are all called coagulant. Those coagulant, when they are adding into the water, and these already, what particle will be colloidal particle? The particle are having the negative charge. If they are negative charge, means they repel each other. They will not be colliding. There will not be any interaction between the particles. Whenever the interaction or collision is there between the particles, they will be interacted. Then the size will be increased, then settle down. Whenever there will not be any interaction or collision, then we can understand that negatively charged particles are there. Those negatively charged particles will be reacting with the coagulant when we are adding. The coagulants are, in general, people are using for water treatment process, aluminum sulfate or alum, ferric chloride and ferric sulfate. These are all the common chemical people are generally used for this coagulation process. When they are adding this chemical into the water, these are all positively charged, and this positively charged particle react with the negatively surface the colloidal particle. Then they have neutralized the particle charge. When after this neutralization, then the particle will be absorbed on the coagulant material, and their surfaces are colliding and interacting. And finally, they are reducing the repulsion between the particle because of negatively charged. Then the particles are allowing to collide, and at last it is settled down. This is the process called coagulation. After coagulation, what we supposed to do? We have to leave this particle for some time. And for that, we are doing aggressively. First, they are mixing the water with the coagulant. Then you have to leave the particle to be settled down. That time, what is happening? All these small particles will be interacted and collided, and they are aggregated into bigger size. Then the density of the particle will be increased. Then at last, they will be settled down at the bottom. This is called flagellation. And settled at the bottom means it is not a precipitate, but it looks like a precipitate. And they are looking like a gelatinous precipitate. They are called flog, or the process is called flagellation. In some time, both this coagulation flagellation will take place in the same unit. But in the large scale operation, and sometimes they are carrying over this process in the different unit also. It depends upon the concentration of the colloidal particle presented in water. Okay. At last, what we have to do now? All particles will be settled or precipitated. It is not a complete or proper precipitate, which is called a gelatinous precipitate. Now we have to separate the clear water from this residue. For that, what they are doing, they are leaving this content in a separate container. In that container, the water turbulence will be reduced or stopped, and they are mixing it, but the turbulence should not be there. And they are separating this clear water from the residue. That process is called clarification. This process is taking place in a unit is called clarifier. Then after separation of residue and clear water, the cleared water is being sending into the filtration process. This is the different stages of water treatment. Now the role of coagulator, I have explained what is the coagulation process. What is the role of coagulation and flagellation in this sedimentation process?
Removal of
Yes,
particles.
yes.
Remove floating particles present in the water.
Yes, okay, yes, colloidal particle, because sedimentation removes only the higher dense particle, higher than the water. And this,
Low density particles can be removed. Yeah.
What's that?
Low density particles can be attracted and removed by this coagulation method.
Yes, exactly. That's all. But only one point extra you supposed to write. Whatever the low dense particles, they are not colliding each other inside the water because they are having a negatively charged surface. When you are adding the coagulant, those are all positively charged. So because of this positively charged coagulant and the negatively charged surface will become neutralized. After it became neutralized, there will not be any repulsion between the particle. So this coagulant will allow to collide the particles, and after collision, the interaction will be there. Then when the particle the interaction is there, then one by one will come and contact, and finally it aggregates into bigger size, then make a gelatinous precipitate and settle down, or sometimes it is floating. So now we can easily separate the residue and also water.
Ma'am,
So yes, ma'am.
can we exactly tell that low density particles are always negatively charged?
I'm talking about only colloidal particles. And especially in water treatment, most of them, because if it is positively charged particle, the thing is, when we are using the air or oxygen, the natural aeration is taking place. Automatically, the particle will be interacted with the air bubble will come. Then there will be, due to the natural buoyancy force, it may move up and it can be removed off, or it make it like behaving like a floatable particle. Then that will be floating at the top. So most of the time, the water particle, whatever it is there in suspension, that is less dense in water, and especially the colloidal particle will be behaving like that only. Is it clear? Some positively charged means what will happen? Then it absorbs air bubbles, and due to the natural buoyancy force, it moves up to the top. Then it will be behaving like a floatable. Understood? Not
Yes,
clear?
understood.
Yeah, because flotation is one of the important stage of water treatment. Where it is used, when I think it is there or not in your syllabus, I couldn't observe. Flotation is a process where aeration was applied. There they have explained. What is flotation? Whatever the particles are suspension in nature, or sometime it is floatable in nature, those particles always we cannot remove, like this colloidal particle. That's what they are following flotation techniques. How they are doing the flotation techniques? They are supplying air into the water, or oxygen into the water, or any some other inert gases into the water. They are making such respective bubbles. These bubbles will be attracted by the whatever the less dense particle which are all in water. They will be attracting and colliding each other. Then the particle size will be increased. Size means only surface area will be increased. The surface area will be increased, but the density is more or less, means the particle automatically rise up and will be floating at the top. That is due to the natural buoyancy forces. This is the concept. How this ship is floating and your papers will be floating on the water, the same thing. Suppose you take a 2 gram weight of stone and a 2 gram weight of paper. Both the substances weight is same, but paper is floating. Paper weight is also 2 gram, but a stone is settled at the bottom, because that is also 2 gram weight only. So the weight doesn't matter, the density is matter. That means 2 gram stone surface area is less than the 2 gram paper surface area. So what? The paper is floating and the stone is immersing. So like that, when the density of the particle is less, either positively or negatively, positive particle will be rising up to the top due to the natural buoyancy forces by the normal activity of air passage. But negatively charged particle cannot behave in such a way. So what they are doing, such a kind of process to remove those colloidal particles. Is it clear?
What are the coagulants added?
Emma?
What are the coagulants added? Name of the
In generally, in a large scale level, always everywhere people are using alum. Alum means which is nothing but aluminum sulfate. Whenever the pH is between acidic nature, from 6 to 8, people are preferring to use alum. Whenever the water pH is in alkaline nature, above 8, then they are using ferric salt. Either it may be ferric chloride or ferric sulfate people are using to do the coagulation process. These are all generally used till date. These are all generally used till date. But nowadays, because of development of this, what we can say, polymeric chemistry, some hydrolyzed aluminum chloride or something like that, they hydrolyzed polymers people are using. That also having the equal efficiency like that. Only the single cost is the matter. And again, the disposal of polymer is the another thing. And the lifetime of polymer will be high, and environmentally it is okay. When we are using alum means aluminum sulfate, what is the problem? Whenever we have the acidic pH, that time only we can use alum. And after adding to the water, again it makes or it forms sulfuric acid. Again, it brings down the pH into acidic pH. We have to neutralize or we have to increase the pH to maintain the normal pH level. That is only the issue. But at a large scale application, when for industrial operation, industrial wastewater treatment, and for our drinking water supply and all, people are not using coagulant, preferring most probably activated carbon treatment only. Is it clear? For industrial application and sewage treatment, definitely they have to use coagulant. Otherwise, the water characteristics will not at all meet the disposable characteristics. So it is must do like that. Any
Yes.
doubt?
No, ma'am.
Okay. And nowadays people have introduced many techniques at a higher dosage, very high level of alum or any coagulation dosage, and which makes the metal hydroxide precipitate, and though that will makes the colloidal particles to be interactive and settle down. And sometimes the people are using the polymers. When they are adding the polymer, which attacks many particles, whatever you have asked the doubt now, if positively charged particle is there, what will happen? When you add this, suppose the thing is some of the particles will not be active, but they may be positively charged. They may not be reactive. That time what they are doing, they are using some sort of polymers. Those polymer will attach the multiple particles, and those multiple particles are linked them together and make it as a or aggregated into as a bigger one to be removed. And the factors which strongly depends upon this coagulation process is pH, because when acidic pH we have to use only alum. Alkaline pH we have to use ferric salt. Even up to 6 to 8 pH we can preferably select alum as a coagulant, but above 8 is definitely we have to use ferric salt only. And alum little costly than the iron salts, and alum makes very bulk flagellant, so the removal is very easy. But ferric salts are making the flagellant, but it is not that much dense. It takes some time to remove, but the economic cost wise, ferric salt cost is less than the alum salt. So this is about the coagulation. If you have any doubt, you please ask me further any explanation. I will give an explanation. We'll have to go a little fast. Please understand. Hello? No one is there or what? I am audible to everyone.
Yes, ma'am, you are audible.
Okay, then we'll jump into the next level.
Yes, ma'am, you can continue.
Yeah, then we'll call up, that is coagulation. Now we will come to the flagellation. After coagulation, what we have to do, the colloidal, we are adding the chemical and the colloidal particles supposed to be interact each other very nicely. So we have to mix them very properly. After mixing, what we have to do, this whatever the colloidal particles are there, that will be interact with the coagulant. Then the smaller particle will be slowly growing into the larger and make it as a denser particle, and slowly it growing into aggregate in a very big, and they will be settled down at the bottom of the container, or sometimes it is floating in the middle like a gelatinous precipitate. This process is called flagellation, I say. Now flagellation means what? Flagellation means which is nothing but you have to mix the content very gently, and also you have to control the mixing. Controlled mixing you have to do. And this process is supposed to promote the collision or colliding between the or interaction between the coagulant and the colloidal particle, but it should not affect the formed flocks, because already flock form or the constant aggregation is formed. Because of this mixing, that should not break. Like that concept we have to apply. For that, what people are using, some of the pedals or impellers or slow speed mixing unit they are using. In such a way, they are carrying over the flagellation. But in a large scale application like municipal water supply or very big large scale industries and all, they are using pedals only because pedals will slowly repeat. How we are pedaling the cycle? Like that, the pedal will be there. The pedal will be rotate very slowly. When it rotates, the mixing will take place, but it will not affect the form of flow. Like that, they are following. Impellers and slow speed mixers and all, there are options, but that is not used much in industries or in municipal water supply system.
1 hour in Canada.
Sometimes people are doing hydraulic flagellation process. For that, the buffles people are using. Buffles also behaving like a pedal, but here and there zigzag manner they are making the buffle. The water is flowing in such a way they are mixing all together properly. Then they settle down. That is also very nice technique to give the mixing for this. And recently, after 19th century, polymeric flagellation people have introduced, which is nothing but some sort of long chain synthetic polymers they are adding. And with that, the particles are bind together, and finally they are making the nice flock, increase the strength of the flock, and thickened flock, it could be easily removed. Now, when they are adding the polymer may be cationic or anionic or non-ionic. I told you that when we are adding the atom, it's supposed to be positively charged, because we decided that all negatively charged particles are there. And some of the, and recently I said some of the particles are positively charged, but they won't be reactive. Such particles are there. Sometime now we are introducing this, especially from the paint industry, varnishes industries and all, they are releasing many products. Some of them will be ionic and some of them will be non-ionic. Those components supposed to be removed, means this polymeric flagellation techniques is helpful. Now, when I am talking, these are all the techniques they have explained in water treatment technology in your book. These are all things supposed to be in wastewater treatment. I don't know why they have included here. I can't understand. This is water treatment. When you are talking about the water treatment, these things will not come. These are all coming in the industrial wastewater treatment concept. I don't know any concept is there or not, but as of me, nothing is there. And non-ionic, whatever it may be, the metal, salt, and the coagulant they are using for the flower formation. And select a proper coagulation, it's mainly depending upon the water characteristics and why do you want to treat the water, the objective of water treatment. All three water treatments are same. Now we are talking about the water treatment. We are not at all talking about the wastewater treatment. But here and there in your have included wastewater treatment concept. Why it has been included like that, I don't have any idea. Now my question is, now you take some water, wastewater or normal water, whatever it may be. All water treatment techniques needs to be done everywhere. Suppose you take water treatment, I have explained about the auxiliary water treatment. Whatever the problem is there, based on the problem, you have to adopt or select the treatment technique. But all industries are following the same treatment. You have any idea? There are different types of industries. Each and every industrial wastewater characteristics will be varied. All wastewater or effluent characteristics are similar. Why we have to talk about industry? Sewage wastewater you take. Every day sewage characteristics will be varied. We cannot say. Even every day, within a day also the characteristics of sewage will be varied. In such a situation, how we can do the proper sewage treatment? So that's what they are telling. Based on the required water treatment and based on the water characteristics, you have to adopt the use or select the use of coagulant. That's what I wanted to say. Because now you take the industrial wastewater, at last what they are doing? They are doing many treatment. At last, in some of the industry, they are reusing the water for the industrial process. In some of the industry, they are using that water for agriculture or gardening purpose. And in some of the industries, they are using
treatment in the STPs. After treatment in the STPs.
Yeah, based on STPs. Yes. Tell me. Yes, sir. STPs.
Now, it's ma'am. And during STPs, they go on filtration and they will use for the gardening or other purpose.
Yes, yes, yes. Yes, in some of the industries, they are using the same water for their industrial application processing also, which depends upon what degree of process, treatment process they are adopting.
Yeah.
That's what I wanted to say. So here also selection of coagulant, which depends upon the characters or the quality or characteristics of water to be treated and the requirement or objective of water treatment. That is the thing I wanted to say.
Yeah, clear, ma'am.
Okay, so this is about the flagellation. The flagellation means which is nothing but you have to mix the coagulant in water in a proper manner. You have to give the proper mix slowly. That is called gentle and control mix, and you have to allow them to settle down in a proper way. How you have to give that mixing? There are three different types of mixing. One is mechanical flagellation. In general, people are following pedals. Hydraulic flagellation in general people are giving by baffle, and polymeric flagellation they are using some sort of charged or non-cationic, anionic or non-ionic polymers. They have provided in such a kind of lengthy strip. All these particles will be stick on it and they are make it as a chain. These are all the ways people are in general doing this flagellation process for wastewater treatment, not for water treatment. You can question on me what is the difference between water and wastewater. If you want, I will explain. Now you
Ma'am, can
please
you
tell
please,
me. Yes, sir.
ma'am, can you please tell
Water and wastewater.
what
So water treatment we are doing, we make the
this
water.
rivarian riparian studies, ma'am?
Which
Rivarian and riparian is what is the term this is related to this wastewater?
your voice is
Riverine
not.
and riparian.
Your voice is not audible to me. Please answer
Ma'am,
that.
ma'am, can you please tell me the term? Can you please
Which
explain
one?
the
Which
term that
one?
riverine and riparian? Riverine and riparian. What is this? Is it related to the wastewater treatment or what is this study, ma'am?
Sir, you please send me in message. Your voice is not audible to me. When we start the next session, I will answer to you. Is it okay?
Okay, sure. Sure, sure,
Sure.
sure.
Thank
Thank
you.
you.
Thank you. Thank you.
Ma'am, these
Yes.
technologies are useful for water which is present, that is the normal water which is present in ponds, lakes and all, right?
Yes. Yeah. How we are getting, I will explain to you in detail. You will not forget in your lifetime.
But
Okay.
not wastewater.
No, no, no. I'll tell you. How we are getting municipal water in Hyderabad? From where we are getting? There are
Godavari, Krishna River.
yes, they have taken water from they are taking water from different rivers, three rivers. Krishna river also, Godavari water also, and Manjira also. These three rivers they are laying for water supply system, specifically Hyderabad city. And how
Yeah.
they are transporting, and then that and all you would have studied how they have explained. I don't know. And I think I have missed out, or you people have missed out. I don't know for that class. And they are taking these three river water for water supply system. Those three water can be used directly for human consumption.
No, unless the treatment we can't use.
We cannot use. Clear? Why? The rainwater quality is not good or anything else has happened.
Yes, yes. During transport, it may be polluted.
No, transport it is going on in a closed system. Nothing will happen. When the water is in river, anything would have happened, correct? When you are walking, you can throw something on the river water. Somebody killed and they have thrown into the water. Correct?
Many
Yeah.
Some dog died,
contamination.
they can throw into the water, is it?
Yes.
And many branches of plants and animals, plants would have been thrown. Like that, many things are there. So what the quality of water from the rain will be degraded.
Yes.
Now we can't say that river water quality is exactly good because of air pollution. That also degraded, but there will not be any pathogens. Please, for your understanding, I'm telling. Pathogens will not be there. Only inorganic and organic constituents will be there. In that inorganic constituent in the form of sulfuric acid and nitric acid will be there. Organic also we cannot assure, only very little. But all pathogens are coming from a human activity only, correct? So what, we cannot use that water. So any water source, if you decide for water supply system, or any water source in village or rural area, people rely for their water usage, that could be treated. Without treatment, no water source or not water sources cannot be used. That is the stages. But industrial treatment, wastewater treatment is different from water treatment. Some of them are similar because coagulation must be same, sedimentation must be same, and some of the process must be similar. But the characteristics of water, normal water and industrial wastewater, by look itself, there is a hundreds of difference, correct? So water treatment is only for making the water source to be conceivable or suitable for human consumption. But industrial wastewater treatment, we are reducing the pollution load to the water sources, and we are making the water to be reused. That is the concept. Is it clear?
Clear, ma'am.
Ma'am, any doubt? Somebody is asking, all water supposed to be treated or not? Is it clear? Okay, fine. Next one is why we have to do this sedimentation process. Now, almost I have told all the point. If you interact more, I can explain more. What is the importance of sedimentation?
To settle down the dissolved salts.
Okay, dissolved salts in the form of what? Okay, now I'll ask you one question. Still, you people are not very clear. What is colloidal particle? Have you seen the colloidal particle in water?
No, ma'am.
No. No one has seen. Okay, I will tell you when you will come. One more class we have in the next week. You take some toothpaste. You take some water in the transparent glass. Put that toothpaste in that glass of water and mix it well. The paste will be dissolved. You have to mix it well. Madam, I put a close-up paste, but it is not dissolved. You should not say. You have to mix it well with a spoon or any stirring rod. Then you can observe that some of the particles from the toothpaste will be suspension in water. It will not be floating, and at the same time, it will not be settled down at the bottom also. Those particles are called colloidal particles. But that will not be dissolved also. But it looks like it is dissolved. What you have done exactly, when you have added the paste into the water, you make them into soluble, but it will not be soluble. Clear? So those particles are colloidal particles. So don't say that is dissolved down. Dissolved particle, how can you remove from the water? Some of the dissolved particles are there. How can you remove? What are the examples of dissolved particles? Everyday life, what we are doing? When you put in salt in water, when you put sugar in water, what is happening? It is completely solubilized, correct?
Yes, ma'am.
What happened? Those things can be removed. How can you remove those? Evaporation is only the technique, no other thing. Otherwise, you have to do that electrolyte test to remove the salt, means Na plus and Cl minus will be separated. Otherwise, you have to do the evaporation process, correct? Now, that is not happening in sedimentation process. That is not happening in sedimentation process. Please try to understand. So, sedimentation process is helpful for two ways. One, it is removing all the floatable or suspended particles which are all heavier than water. Next one is sedimentation. There are two types of sedimentation. One is plain sedimentation. Another one is sedimentation with flocculation and coagulation and flocculation. Plain sedimentation, you just leave the water in still condition. There the particles which are all higher dense than water will be settled down at the bottom by natural gravity. And sedimentation with coagulation and flocculation, whatever I have explained now, you have to add some of the chemical, those are called coagulant. Then the particle which are all less dense than water, which are all suspension in water, will be aggregated into bigger particle. Then it will be eventually settled down at the or eventually it forms like a gelatinous precipitate called flagellation. Then the flag would be removed from the water. When we are doing such a process, what will happen? Whatever the microbes are there in the water, like pathogens and some of the algae, that also will be attached with those particles, could be removed. And sometimes because of this acidic nature of this coagulant, some color will be removed, some organic matter also removed. And for example, what people are in general, they are telling, when we are doing this sedimentation process with coagulation and flagellation, which remove around 90 to 90% of pathogens from the water, and also which will be easily removed from the sedimentation process without much effort. When we are doing such a things, the load of pollution to the chlorination process will be considerably reduced. So the efficiency and the effectiveness of treatment will be good. Yes, any question, please?
Ma'am, can you repeat? It is disturbing. Voice is disturbing.
Okay. Right from starting, okay, I'll tell. There are two types of sedimentation. One is called plain sedimentation, and another one is called sedimentation with coagulation and flagellation. In plain sedimentation, you have to leave the water under still condition. That means you should not give any turbulence or any velocity, anything. It's supposed to be still, stagnant condition. Then whatever the particles are higher density than water will be settled down at the bottom by natural gravity force. That is called plain sedimentation. And the next one is sedimentation with coagulation followed by flagellation. What is that? Whatever the particles are called colloidal particles, those are all less density than water. Those particles will be suspension in water. Those particles will be removed by when we are adding the coagulant, and those particles will be interacting with this coagulant. Then the smaller particle will be aggregated into the bigger one. Then eventually that will be settled down at the bottom, or it makes the gelatinous precipitate called flag. That could be easily removed. When we are doing such a process, the water may have some of the pathogens like bacteria or algae or fungus or whatever it may be, along with some of the organic matter which comes out of any living things. If the color of the color also is there in water, those also could be removed to some extent from this sedimentation process through coagulation and flagellation. They, in general, people have reported that not now, many years before, 2 centuries before, this sedimentation process could remove 90 to 95% of pathogens. And some of the organic matter, which are all harmful, and some of the coloring substances from the water or color also from the water could be removed by this process. And following up this process, when they remove 90 to 95% pathogen, which makes that final stage of treatment, chlorination or disinfection, should be easier and simpler, and also which increase the entire efficiency of this treatment plan. Because chlorination is a process, we have to add chlorine into the water. You know that. Now I'm going to give some statistical information which I have collected from the Hyderabad in 2014 or 15. One student was there from the Hyderabad municipal water supply system. Per month or per day, I don't know. I think per month they are spending 20 crores rupees for only disinfection process. 20 crores. Only because there are different stages of process. They have to take the water from the river, they have to pump, and they all the way from Krishna, Godavari, Manjira to Hyderabad to the treatment plant, then different stages of treatment, and then they have to check the quality of the water in each stages, and finally they have to do the disinfection process, nothing but chlorination. For that chlorination process, they are sending per month 20 crores. At least now I am requesting you people, don't waste municipal water. We are thinking we are opening that tap and That means that time cost is around 40 paise per liter they have spent. 40 paise per liter. Now it could be more than that. Now 2014 statistics I am giving. 40 paise per liter of water they are spending for only treatment. How much water bill you are paying, how much water you are wasting, how carelessly we are handling the water, we are aware of it. Now, please, it's my humble request as a staff, I am requesting you all, please don't waste water. Please consider one side from the reducing the water pollution and another side, you please think of treatment cost. Hello?
Yes, ma'am.
Not interesting. This madam is telling something different, you may feel it's okay, fine, no issue.
No, ma'am, it's interesting. You can continue.
You know that these are all, we are studying environmental science. If we are not bothering about the environment, who will bother? Is it? And everybody, all policymakers are many thousand crores of people are there every day. They are sanctioning many crores project to the university research organization, this, that, and all. At last, what is the environmental picture is there in the government and state government, central government, and what I can say globally on the paper, on the top for the past 150 years. What is the status? Now the entire global has affected. What happened? What happened? The technology has developed, techniques have been developed, people are doing many research, the paper is being published, many PhDs are coming out, many technologists are coming out. Okay, fine. They have introduced some of the techniques here and there, and somewhere people are following, somewhere they are not following. Industrial pollution level has been reduced a lot, that I have to agree. The thing is, at last, what is the status of environment? Any one of you can answer, what is the status of environment now? How is the environment is polluted or still not yet polluted?
It's keeping on degrading, ma'am.
Because of what? Because of what? You and me are the reason or somebody else is the reason?
Anthropogenic, human beings.
We are only the reason, correct? Anthropogenic, who is that anthropogenic? We are only,
Humans.
na?
Human beings are the reason.
We are only, correct? So that's what the last year, about the last year student, I would have told in the last class also. Many students have taken many revenge to protect the environment. For walkable distance, they are walking. They are not using much water and prefer to go by public transport. Even they are very rich. Like that, many decisions they have taken. Because they felt that we have lived comfortably, but when our grandchildren will come, they may able to breathe or not, we do not know. And they may able to drink water or not, I do not know. Then you can say that water filter system will come. Are you trust on the water filter system? I am not trusting. You know that when we check the history of any governmental hospital or any big private hospital which is working for quite a long time, more than century, the number of patients, those who are having the bone and teeth problem in 20th and 21st century is more than the 18th and 19th century. What is the reason behind that? They have analyzed. That is through only because of water. Whatever the filter water we are drinking, those that filter is filter it of all the essential mineral. Whatever the water we are drinking that does not have the essential mineral. So the phosphorus, iron, calcium, whatever it needs for our bone and teeth, we are not getting. So after 40 years, 50 years, most of the people are having the leg pain, knee pain, joint pain. But earlier days, it was not the case before introducing this water filter. So that is the thing. So drinking water filter water is not at all good that everybody knows, including the company who is producing the product. Clear? And the intelligence people are using only boiled water for drinking. Okay, leave it. What do you want to do? As a teacher, I want to tell the problem. Then the option is your personal. So you can decide, and but we are have habituated with that taste, so we will not do. Application and benefits. What is the application and benefit? Again, I don't want to tell all those things, everything I would have told. We'll go little fast to cover the syllabus. I don't know whether we can cover the syllabus or not. So that is very important. What is the limitation of the sedimentation process? Can you tell? What is the limitation? It is not much problematic process, correct? Because we are not using much electricity. We are not using very costly chemical and also highly reactive chemical. These are all very easy. Only thing is, I told you, the pH is very important thing. And you have to maintain the pH. The acidic pH means you have to select alum. Alkaline pH means you have to select parasol. Alum is costlier than ferric salts. So you have to select accordingly. And alum gives very bulky flock, but the ferric salt gives very light flock. And one more thing is, I told you that you have to make the water in stagnant condition without any disturbance. That is also very, very important. When the amount of sludge, whatever sludge means residue after adding the coagulant, that is sludge removal is important because which may contain some of the valuable organic matter also. Those could be used for something. That organic matter could be used for any biogas. Biogas means gobar gas generation, and proper application of that sludge will be giving the more economic value. These are all positive things. And another point of thing is you have to think about the cost of coagulant because alum is little costlier than the ferric salt. That is only the problem. pH, cost, and sludge formation. No other negative or limitation for this process. Clear? So sedimentation is one of the important process. There we can play with the only pH and the cost. Then we can get the good treatment process. And this will be effectively increasing the efficiency of any treatment plan, not only for the wastewater treatment plan. And application of sedimentation process. Anyone can simply tell what is the application? We know that this will be useful for the municipal water system, industrial applications, and also when we are using these two places, obviously which will be helpful for indirectly or directly environmental management, right? Yes or no?
Yes, ma'am.
And one more important problem is there that I forgot to tell you. Sometimes very carefully when the heavier particles are there and which makes the flock very heavy. At the time when that whatever the organic matter, algae, fungus, some pathogens, everything will be removed from that. Sometimes what will happen? Already I know this turbidity of water will go and particles which are all in the suspended form will be going. And when we remove these two type of particles, the further treatment process is only two. One is filtration, another one is disinfection. So which will be effectively remove this turbidity and the suspended particles, then they will be increasing the effectiveness of filtration and disinfection process. And whenever the inorganic substances are there, inorganic substances means what? Some of the settleable solids, grit particle, and those are all coming from the sewage. And at that time, what they are doing, all these particles will be settled down by this coagulation process, which eventually or efficiently reduce the biological oxygen demand. That is very important. What is meant by biological oxygen demand or BO? Biological oxygen demand means simply they are telling that is called BOD. What is BOD? Anyone can tell, please?
The dissolved oxygen required to break down the microorganisms to break down the organic matter present in the water, like lakes and ponds.
Fine, fine. Very good, very good. That means the amount of oxygen required for the respiration of microorganism which is present in the wastewater, correct? When they are consuming those organic matter present in water. When we are doing this process, sedimentation process, whatever the organic matter there, it will be removed by this sedimentation process. When it is removed, then obviously the biological oxygen demand will be reduced, correct? Understand?
Yes, ma'am.
From that concept only, whatever the concept I have applied, please, it is wonderful point. Because of that concept only, this coagulation process initially developed for water treatment. Because of this concept, they have introduced this coagulation followed by sediment, followed by flagellation in wastewater treatment also, especially in secondary treatment. Why? In secondary and tertiary treatment, what is happening in wastewater? They are make that water free from the pathogen and other harmful bacteria. From that, they are deciding the water could be reused for further processing or human consumption like that. So this is one of the important advantages of this sedimentation process with coagulation and the flagellation.
Sedimentation, eutrophication.
What, ma'am?
Sedimentation indirectly prevents eutrophication.
Yes, obviously, because it settled down at the bottom, the whatever the organic matter which is heavier than water, na? Clear?
Yes, ma'am.
Obviously. So this is about the sixth lesson. It is almost over. Then we'll continue the lesson 7, that is about the filtration process. If I'll give 5 minutes time, if you have any doubt, you people discuss and ask me the doubts about the sedimentation process or aeration process or any water treatment process. Anything, if you have doubt, I'll give 5 minutes. Before I start up the unit 7, you please stay. Okay? Hello? I'm
Ma'am,
audible to you. Yes. Any doubt means I will give 5 minutes time. You please ask me.
in sedimentation, Stokes' law is mentioned. Can you please explain, ma'am?
Which, what, ma?
Stokes' law for particle settling.
Zona.
Stokes' law, ma'am.
Stokes law, it is a law. Okay. You want
Once
to know?
explain, ma'am.
Yes. Actually, when we are talking about this sedimentation process, the sedimentation, any process if you take, that is play with the density, volume, and viscosity. Okay. The parameter which affect or the factors which are affecting the sedimentation process is, one is size of the particle, another one is density of the particle, third one is viscosity of the solution, and density of the particles, and the velocity of the flow, velocity of the water. These 5 parameters or factors are affecting the sedimentation process. Now, here, the Stokes law, what they are telling, this sedimentation process, they have explained in terms of Reynolds number. Whenever the density of the particle is increases, the sedimentation process will go fast. Whenever the viscosity of the particle, viscosity of the liquid is more, then the sedimentation will go slow. That's what the Reynolds number will be directly proportional to the density and inversely proportional to the viscosity of the fluid. And another one is velocity. Whenever the horizontal velocity is more, horizontal velocity is more means the surface area is more, then the horizontal velocity will be reduced. Whenever the horizontal velocity will be reduced, then the sedimentation rate will be going up. This concept is being explained by Stokes in terms of Reynolds number. Reynolds number equal to density into V into diameter of the particle upon viscosity of the fluid. Is it clear?
Yes, ma'am.
Okay, fine. Any other thing?
Ma'am,
Hello. Hello. Hello.
yes, ma'am, we are there.
Any doubt? We'll start the next unit.
Ma'am,
Yes, yes.
ma'am, how is the temperature also? How is the temperature also affecting the sedimentation?
Okay, sure, I'll tell. Suppose now you think that because we are talking about the water or wastewater treatment, okay? Any viscous fluid may mix with that. If the temperature increases, now we will directly say viscosity will increase or decrease the sedimentation process.
Viscous will be decrease the sediment process.
So when we increase the temperature, that the viscosity will increase or decrease.
Viscosity will be decrease.
If the viscosity will decrease, means sedimentation will increase or decrease.
Increase.
Increases. So that is the role of
Sedimentation will be decrease.
increases. That is the role of temperature on sedimentation process. So this will not be adopted always. Whenever the viscous fluid is mixed with the water or wastewater treatment, then they are playing with that. They will provide some temperature. Otherwise, for normal water treatment, it does not require.
Okay, ma'am, thank you.
Okay. Any other? So it will be terminated within 1 minute. The meeting will be terminated within another 2 minutes. So we'll start the lesson next unit after 2 minutes, or we'll start now. It is your choice.
After 2 minutes.
Okay, then go ahead and we'll connect and we'll join. We'll continue. No issue. Okay. Meanwhile, if you have any doubt or clarification on treatment techniques also, you can ask me. No issue at all.
Ma'am, last class we missed. Can you please give recap of aeration?